Welcome to the lecture series of Mathematical Modeling of Manufacturing Processes with subject code KME 073. I am Dr. Suman Gotwal, working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So today we are going to start one of the important topic, that is overview, methods and classification of mathematical modeling. In this lecture, we will see what is the mathematical modeling and what is the requirement of it. This will be the outline of today's lecture. First, we will discuss about what is mathematical modeling, and after that, we will discuss about the statistical and data driven mathematical approach. Then we will see what is the importance of mathematical modeling and what are different stages and processes of the mathematical modeling. Then we are going to discuss about the different factors, or we can say the different parameters of the mathematical modeling approach. Then we will see its applications in the field of engineering or our daily life. Then we will see what are the different methods that we can use for this modeling approach, and at last we will see the classification of the mathematical modeling. Okay. So first we will discuss about the introduction to mathematical modeling. So what is a model? Model is a way to represent something. Okay, or we can say these are the tools which are used to understand the behavior or the different processes which are involved in the real world problem, and on the basis of these we can make the inference about the future. Okay, so model is the way to represent a system, a activity or the behavior or the different parameters which are involved in a system. So next question that arises is what are we supposed to represent? Okay, so we can represent the nature, the behavior or the different activities which are involved in a system. Okay, and if these activities are represented in a proper format, then we will get a mathematical model. Clear? So what we will represent here? We can represent different activities, we can represent the behavior of the system, or we can represent the different problems, different parameters of a system. Okay, and for a mathematical model we have to represent all these activities or the activities that are related to a particular problem in a proper format. Okay. Next is what are the ways to represent, means how will we represent these activities or these problems. Okay, so we can draw it or we can represent it with the help of verbal arguments also, or we can make a physical structure. Okay, or we can relate the different parameters with the help of the mathematical formulas. So these are the different ways by which we can represent the different issues which are under consideration. Okay, so what are the ways to represent? We can represent the activities with the help of drawings, or we can represent it with the help of the verbal arguments. Okay, or we can make a physical structure, and we can use the mathematical formulas also. Okay, so these are the different ways to represent something. Now, we can define the mathematical model as it is a process of representing the system. We are representing the system here. So, we can say it is the process of representing the system with the help of the mathematical formulas, and the structure which we will obtain is known as the mathematical model. Okay. Now, we come to the statistical and data driven modeling approach. So, if we talk about the modeling approach, so in science we can say that there are two types of modeling approach. First one is the data driven models and the second one is the process based models. So, within the scope of our subject or this lecture, we will focus only on the statistical and data driven modeling approach. So, what is the data driven modeling approach? Data driven, it means it is derived with the help of data, or we can say it is based on the data. Okay. So, we can define the data modeling approach as the data driven models build the relationship between the input and output data without worrying too much about the underlying processes or using the statistical and machine learning techniques. Okay. So, here we are establishing a relationship between the different variables. And what are these variables? These are input variable and the output variable. So, we will establish the relationship using the different techniques or different methods. Here, because it is the data driven, we will not focus much on the process. Okay, on the processes, we will focus on the data, and on the basis of data we will conclude the things. Now, what is statistics? So, it is the study and manipulation of the data, and this process will include the ways to gather the data, means how we collecting the information, and after collecting all the information which are related to a specific activity, we will review that data, and after reviewing we will analyze and we will draw the conclusion. Okay. So, it is the complete process from starting from the collection of data and the drawing the conclusion from the data. Okay. So, what is the statistic model? So, statistic model, we can say it is the mathematical represent of the observed data, means what type of conclusion we are drawing from the data. Okay. So, we can say the objective of the statistic modeling is to summarize the test results. Okay. और कैसे results summarize करने हैं? So that the evaluator can observe the data pattern. Okay. When we are collecting the information here and we are analyzing the data here, we are basically observing the pattern of that particular data, and on the basis of that data we are drawing the conclusions. Okay. And then after concluding the data, we are inferring the future. Okay. We are predicting for the future. Okay. And if we want to establish the relationship between the input and output data, then a large amount of data will be required. Okay. Okay. Now, we come to the example. So, first example we can say is the linear regression model. So, in linear regression model, basically it is the data driven model, and here also we will establish the relationship between the dependent and the independent variables. Okay. We will plot a graph that graph is between the dependent and independent variable, and this model can be used to understand the relationship between the different variables, and in some cases it can be used to make the predictions also. Okay. So, it is the perfect example for the data driven modeling approach. So, on the basis of the previous data that is available with it, we are drawing the conclusion and we are predicting for the future. Another example is the language translator or the Google Translator. It is also based on the data. It is using the different techniques. Okay, it is using the, for example, it is using the deep neural network based statistics and probabilities for concluding the data, for concluding from the data. It doesn't know about the grammar rule of the language. Okay, it is not having the information about the grammar rule of the language. It is giving us the information based on the data only. Okay, now we will discuss the importance. What is the importance of the mathematical modeling? Okay. So, what is the need of mathematics to represent the system? If we want to understand the system, we have to identify the different variables which are associated with the system. Okay. And we can relate those variables, or we can relate the impact of these variables on each other with the help of mathematics or with the help of the mathematics formula. Okay. And in the analysis of the system, the mathematical model plays a vital role which other models like physical, chemical, linguistic, etc. cannot do. Okay. With the help of mathematical formulas, we can easily relate the different variables which are related to a system, and we can draw the conclusion on the basis of it. Simulation of model rather than experiments of the actual system. If we want to do the simulation on the models, then we can use the mathematical modeling approach, because if we are doing the experiments on the actual system, then our energy, our time, our cost and the other resources will be wasted. Okay. So, we give the preference for the simulation on the models. And why we do the simulation? To check the performance of our model, and which these models will be similar to the actual system. Okay. If we want to understand the physical behavior of the system, how the system will behave in a how the system will behave. So, if we want to check the behavior of a system, then in that case we can use the mathematical model. If we want to do the measurements, okay, so it is the economic way. Okay. If we want to control the parameters, because we are relating the different parameters, so we can see the impact of each parameters on the system. Okay. And if it is impacting an a great extent to the system, then we can control those parameters and we can improve their parameters. Okay. To predict the future nature which have not been seen so far. So, we can take the example of the forecasting methods. So, forecasting techniques which are also based on the previous data. There, and in forecasting also we collect the data, we analyze the data, and then we draw the conclusion from the data, and then we predict for the future. So, here also we are using the mathematical approaches. So, in engineering and technology, it provides the analytical basis for design and control in which the prediction can be made without spending valuable resources of money and effort. So, we make the model before making the actual system, and we perform the testing on the models, so that we can save our money and effort and time or other resources. Okay, now we come to the different stages which are associated with the basically mathematical modeling. Okay. So, if we talk about the different stages of a mathematical model, we can see here it is divided into the different stages. So, first it is starting with the real world problem. So, because we want to analyze the actual system. So here we have the real world problem. Okay, we are selecting one system or one issue or one task to which we want to analyze, and we are simplifying it. How we will simplify it? We will make some assumptions, and with the help of those assumptions we will simplify it and we will convert it into the working model, okay, to which we could analyze it. Now the working model represents a mathematical model. Now how the working model will be converted to the mathematical model? With the help of the variables or parameters which are associated with this working model, we will convert this working model into the different equations. And when we represent those equations, because equations are basically showing the relationship between the different variables, so we are representing it into the form of the mathematical model. Means we are representing those equations in a proper format, and after that we are getting this mathematical model. Then we can say the next step is the translate and computational model. So in case of the computational model, basically we are using different techniques, different methods to solve those equations, okay, which are showing the relationship between different parameters of the mathematical model. So here we will do the calculation part. Okay, after calculating the part we will simulate, and after the simulation, means here we are using different processes, we are using different procedures, techniques or methods to solve those equations, or we can say we are testing our model here for to check the performance. Okay, so we are simulating our model here, and after the simulation we are getting some outputs, and on the basis of those outputs basically we will conclude. Okay, we will conclude, and after the result and conclusion, the next step is the interpret real world problem. Okay, and after getting the result and the after drawing the conclusion from the simulation and the computation model, what we will do, we will check our output, means whether it is in the scope of the real world problem or not, or whether these are giving the exact output which we required. Okay, so if there is any deviation, then again we will establish the relationship, or we will write the equation. We will again we will again move to this stage here. If we get the deviation, we will again construct the equations. Okay, so these are the different stages of the mathematical modeling, which is starting from the real world problem and which is ending at the result and the conclusion. Now we come to the process of mathematical modeling. So in this process we are taking the actual system, means it is same or which we have discussed in the previous slide. So we are basically starting with the actual system, or in actual system there are different parameters or there are different measures. So first step is to define all the parameters or all the variables here. Okay, and after defining the variables and the parameters, what we will do, we will construct the equations. Okay, so that we could relate these parameters or the variables. And after constructing the equations, we will check whether these equations satisfying the actual model or not. Means it should include all the aspects of the system. Okay, so we will check here whether our equations are satisfying the actual model or not. If it is satisfying the actual model, it means we will compute our model for the outputs. We will use different techniques or methods for the output, means we will solve these equations. Okay, and if these equations are not satisfying our actual model, then we will go again to define the variables. Means agar equations are not satisfying the actual model, it means we have not defined parameters or variables properly. Okay, then we will again define the parameters and variables, and after computing the models for the output, we will check whether it predict the original system or not. Means we are exactly getting the same output as the actual system will give. Okay, if it is predicting the original system, then in case we will validate our mathematical model, and if it is not predicting the actual model, then we will again construct the equation. Okay, so this is the complete process of the mathematical model. Now we come to the different factors which are associated with the mathematical modeling. So after developing a mathematical model, there are some parameters on which it should be judged for the applicability. So there are some parameters for which we will check for its applicability. Means it will be applicable to our system, it will be applicable to our actual system to which we want to analyze. Okay, so few of the parameters are, first one is the scope. Okay, scope is basically whether our mathematical model is considering all the aspects of our system or not. Okay, so we will check the mathematical model for the scope. Means is the model able to define the scope of the chosen real world problem? Okay, so we will see here that whether it is within the scope or not. Complexity. So in this we will see our model should not be too simple or too complex in terms of the parameters involved. Okay, parameters or the variables which are involved in the system and on the basis of which we are creating our mathematical model should not be too simple or too complex. Okay, and are they sufficient enough to represent the actual nature? Okay, and whether they are representing the actual nature of our selected system or not, we have to check here. Then we come to the computation. So in the computation, basically we will see for the computation cost, because here we are using different software, different processes, different techniques for solving the equations. Okay, so it is associated with the cost, so it should be reliable one so that we can adopt it. Accuracy. So what comes under the accuracy? Does the model produce accurate or close to accurate output, and it will be with respect to the actual system. Okay, actual system. So in respect of actual system, we will check the accuracy of our mathematical model. Then we come to the stability. So what is the stability? Stability is basically the state of being steady or not changing. So our model should be stable enough, it should not change with the parameters, with the outside factors. Okay, so it should be stable one. Then we come to the consistency. So what is the consistency? It is basically the quality of having the same standards or opinions or the behaviors. So we will check whether the our model misbehave with the given perturbations. Perturbations means if there is a small change in the physical system, then whether our model is stable or not, whether our model is behaving properly or not. Okay, it should not change. So these are some parameters for which we have to check our mathematical model. Now we come to the applications. So different applications where we can use the mathematical model. So mathematical model has application in every field of engineering and science. Almost everywhere we are using the mathematical models. Okay, for example, if we want to study the crime rate, and this objective to study the crime rate is related with the sociology. Okay, if you want to study the crime rate, then we have to check the past data, we have to analyze, we have to conclude from the past data. So it will be the statistical and data driven modeling approach. So here we are using the mathematical modeling. Okay, to construct a building, if you want to construct a building, it is related to the engineering field, then also we will do the planning. Okay, before actually constructing the building, we will make a model, we will do the planning, and after that we will construct the actual system. If we want to analyze the patterns in the planets, if we want to analyze the movement of the planet, or we want to study, we want to understand the patterns in the planet, then also we have to analyze the data. Okay, so we have to analyze the moment, or we have to analyze the past data. It will also help to understand the universe and the conditions needed to sustain the life. So in the universe or on the earth, different type of conditions are required to sustain the life. So we have to understand those conditions, we have to relate those conditions, and we are relating those conditions, we are analyzing this with the help of mathematical model only. Mathematical modeling is capable of saving the life, assisting in policy and decision making. So if we want to make some decision, then also we use some techniques. For example, we use the decision making techniques. So if we want to take the decision, we can use this approach. If we want to help in making the policy, that policy can be for the any type of system. And if we want to save the lives, means we want to identify the factors which are harmful to us, then we have to analyze the different type of data. So in all these applications we can use this. If we want to optimize the economic growth, then also we can use this mathematical modeling. If we want to solve the problems in the military operations, then we can use this. So these are some of the applications of the mathematical modeling. Okay, now the different methods for the mathematical modeling. So there are different types of methods for the mathematical modeling. So main three types of mathematical models are: first we have the forward modeling, second we have the inverse modeling, and the third one is the mixed modeling. So what we do in the forward modeling, basically it is solved for the outputs, okay, with known or assumed inputs. So here inputs are known to us, and we will solve our mathematical model, we will solve our equations for the output. And mostly forward modeling is used because we know the input and we want to go for the output. Okay, so in any industry, we can take the example of any industry. In production system, we have all the input, we have the input in the term of the resources available with us, and we want to calculate for the output. Okay, inverse modeling means when we solve for the input and or outputs with known states and the parameters. Okay, so here we are knowing the outputs, we know the outputs that this is the output, but we want to calculate for the input, so it will be the inverse modeling. Okay, for example, we want to either maximize the profit or minimizing the cost. So our objective is known to us, and for this maximizing the profit, what type of inputs we have to use. So this is the example of inverse modeling. But in some of the problems we use the mixed modeling also, in which is the mixture of the forward and the inverse modeling. Means if we are analyzing an actual system, then in some of the part we are using the forward modeling, and in the remaining part we are using the inverse modeling. So other techniques are also available with us. So these are basically the classical approach. In case of the classical approach, we basically have the differential, integral, differential, or difference equation. So all these will be involved in this type of approach or the classical approach. Then we have the stochastic approach. So in case of the stochastic approach, basically जो statistical methods, okay, which are based on the data only, or the probabilistic models, okay, which are based on the probability, or the stochastic differential equation. So our model is based on the statistic method, probabilistic or stochastic difference equation, then it is known as the stochastic approach. Then we have the computer simulation. So under this category, basically it is used where the analytical or the and analytical methods are difficult to use. So, there we will use the computer simulation, so that we could check the performance of our actual system. So, we do the simulation with the help of the model solve. Then we have the operation research. So, all the optimization techniques or the control theory will come under the operation research. So, example of optimization techniques like the linear programming, simplex methods. Okay. So, all these are the optimization techniques. So, all are part of the operation research. Other methods like the fuzzy logic, topology or differential geometry, etc. These are the other methods which we can use these to solve the mathematical problems. Now, we come to the classification of the mathematical model. So, we have classified the mathematical models on the based on the different parameters. So, first of all, we have the linear and the non-linear methods, okay, or linear or non-linear model. So, in a mathematical programming model, if the function and operators are represented entirely by linear equations, okay. So, in case of the linearity, what will happen? All the functions and operators which are involved in a model, if they all are linear in nature, then it will be known as the linear model. Okay. For example, we have taken this equation f my plus nz is equal to m dot fy plus n dot fz. So, all the factors and operators involved in this equation are linear in nature. Okay. So, we can see here all the function and operators in a mathematical model exhibit linearity. Okay. If there are some non-linear terms are involved in our system, then we can use some techniques to convert into the linear one. Okay. The resulting model is identified as the linear one. Otherwise, the model will be the non-linear if the non-linear term are involved in it. So, these are basically simple to analyze because linear terms are involved here, all the functions are linear in nature. So, these are easy to analyze if we compare it with the non-linear models. Okay. If we want to analyze the non-linear model, so there are some techniques which we can use to convert the non-linear model into the linear one. Okay. So, we are taking the example here for the linear and non-linear equations. For example, if we have the equation y n plus 1 is equal to a y n. So, we can see here that all the terms involved in this equation, particular equation, are linear here. So, it is the example of the linear equation, but if we consider this one, then what will become a y n if we will expand it, and it will become a y n square, okay, and this will become y n plus 1. So, this equation will become this. So, here the non-linear term is involved in this equation. So, it is the example of the non-linear equation. Okay. Now, we come to the another classification, which is the static or dynamic models. Okay. So, what are the static or dynamic models basically? Static or steady state. So, static is also known as the steady state models, means these are the models which will calculate our system when it is in equilibrium, and it is the time invariant, means it will not change with the time, it will be in steady state. Okay. It will not vary with the time. Okay. And dynamic model account for the time dependent changes in the state of the system. Here the state of system will change with the time. So, these are time dependent variables. Okay. And these are typically represented by difference equation or the differential equations. Okay. So, this is the example of the static system, x is equal to y. So, it is not depending on the time and it will be static in nature, it will not change with time. So, it is the static system, while x is equal to yt, it is an example of the dynamic system, because here it will change with the time. As the time will change, our state of the system will also change. So, it is the dynamic system. Next, we come to the discrete time or the continuous time models. Okay. So, in discrete time model, basically a discrete model treats objects as discrete, such as the particles in a molecular model or the states in a statistical model. Okay. So, we can say in discrete model, basically the events that are happening in our system, these are categorized within the time interval. Okay. So, these are basically countable. Okay. We are not, these events are not happening continuously, these are happening in the time interval. So, we can count it. So, for example, yn plus 1 is equal to ayn. So, this is the basically this is the discrete model example. Continuous time model. Continuous time model is basically which is happening continuously. Okay, means event will takes place at every point in time. For example, we can say the time between the birth and death. So, between the birth and death, events are happening continuously. So, it is the example of the continuous model. Next, we come to the deterministic and stochastic model. So, what is the deterministic? Means in which every variable state involved in the system can be uniquely determined. Means all the variables which are associated with the system have a particular value, have a unique value here by the parameters or by set of previous state of these variables is known as deterministic. For example, the length of the hypotenuse can be determined from the length of base and perpendicular on a right angle triangle. So, this will be the example of the deterministic model. Okay. So, we can say that the deterministic model always perform the same way for a given set of initial conditions. In case of the stochastic model, randomness is present. Okay, and variable states are not described by unique value. So, here the probability will be there, randomness will be there. So, the variables which are involved in the system will not have a unique value here, and rather by probability distribution. Okay. The example is the prediction for raining in the next one. We can predict it. So, the event might happen or it not happen. So, probability will be there. Next, we come to the autonomous and non-autonomous model. So, in case of the autonomous model, these are the one in which the system of ordinary differential equation does not depend on the independent variables. Okay. So, here our equations are independent on the independent variables. Okay. If the variable is time, because our equation is not depending on the variables, so it will be time invariant model. We can take the example of this equation, dy by dt is equal to y. So, it is the example of the autonomous model. Okay. So, any system or any autonomous system can be transformed into the dynamic system or vice versa with a very weak assumptions. Okay. A system which is not autonomous is called the non-autonomous system. So, here we can see here that differential equation is dependent on the time variable. It is depending on the variable. So, it is the non-autonomous in nature, but if it is independent on the variable or it is not depending on the variables which are associated within the system, then it will be the case of the autonomous. Now, we come to the explicit or implicit models. So, if all the parameters of the overall model are known and the output parameters can be calculated by a finite series of computation, then the model is said to be explicit in nature. Okay. So, here we know the input parameters and we are calculating for the output parameters. And if the output parameters are known and we are calculating the input parameters, then it will be implicit in nature, and it will be, we can solve these type of models with the help of the iterative procedures, like we can use the Newton methods. So in such a case the model is said to be implicit. Okay. These are the references